Now, this is a tricky question. It's going to take a while to talk you through this one. So, first of all, we have a car, all right? So let's look at a car. And we've got like 3 stages. He starts at rest. Let's call this at x equal to 0, and his velocity 1 is 0. And then over the first segment, he is going to accelerate for a given time. So he's going to accelerate. We're going to go A is 4.6. Oh, pardon me, that's not correct. That's not A. Erase this. A equals 2 meters per second squared, and T is 4.6 seconds. So what I want to do is I want to find out how big is this x2, basically, right? And so I'm going to use the kind of the big equation, right? The master equation, the first equation, x2 equals x1 plus v1t plus 1/2 at squared. Well, x1 is 0, right? Because it's starting right here. This is like x1 equals 0. Plus, what's the initial velocity? Oh, that's 0. So 0. So these two terms just drop off. Plus 1/2 times 2 times 4.6 squared. That's going to give you how far he travels in this first segment. Got it? Now, what happens next? He then coasts for 3 seconds. Now, what does that mean? He coasts for 3 seconds. That means that he's going to be traveling at a constant speed for our second segment. So he's going to be at this distance and this distance. So we're going to use, really, honestly, actually, you know what I need to do? I need to do 2 things. How fast is he going here? Because without knowing what is his V2, so from this one, actually, I need to do one more thing. I need to find out what V2 is. And so what I did, what did I do? Yeah, I just used the third equation, V2 squared equals V1 squared plus 2a change in x. Now, change in x is the number that you've just calculated right here. And now I can find what V2 is. Now, V2, this V2 that you get will really be the V1 at segment 2. So watch that. So this V1, some kind of a coloration. I'll make it black. Whatever you get here, the black number goes here, right? So that's your V1 in this problem, because now what I want to do is I want to figure out how far they'll travel. And so I'm going to say x2 equals x1 plus v1t plus 1/2 at squared. Now, note here, he's at constant speed. He's coasting. So he's moving at the same speed. So the acceleration is 0. So this last term drops off. And you could actually take the x1 you get here and put it here, but I wouldn't. I would just do x2. I just want to find out how far in this segment that he travels is equal to 0 plus. Now this will be black number, right? Black number v times, and we know this to be 3.01 seconds, because then this last term is 0. That will be the answer for this segment. Now I've colored black. And then we have the green section, if you will, make it green. So that's when he taps the brakes and he decelerates. So when he taps the brakes, we know, again, we still know what his, so I'm going to use the same equation. I'm going to say x2, I'm going to use the third equation, v2 squared equals v1 squared plus 2a delta x. And I want to solve for the x right here. V2, he's going to a stop, right? Because he slows down to the next stop sign, right? Equals, now this will be the V1 is the speed he has here, which is our black number, V1 squared plus 2 times, and it says that his deceleration is negative 2.3 times delta x. Solve for delta x, and that'll be some number. Maybe make this the green number. And you're going to then add, the blue number. So it'll be this plus this plus this. So kind of a convoluted problem because you have three separate parts and you have to figure them out one at a time and then add them.